one here, we have x to the power n, e to the power ax. So in this case, you choose your u. Remember that integral, the integral of u dv equals to uv minus the integral of v du. So you choose your u to be x to the power n and your dv to be e to the power ax dx. Then you differentiate. So you differentiate to determine du, you integrate to determine v. So that's the process that we are going to follow. Okay, now because of space, we can use OneNote. So here we are given the integral of x e to the power x dx. So according to the situation, they said, according to the hint, they said we choose u to be x and dv to be equals to e to the power x dx. Now we differentiate here. Du is equals to dx. We integrate here. V is equals to e to the power x. Okay, we don't include c. C will put it on the final answer here. Now we write down our formula. Our formula is we integrate u dv is equals to uv minus the integral of v du. Now what remains now is to substitute. My u here is x and my v is e to the power x minus the integral. We substitute v. My v is what? Is e to the power x, and my du is what? Is dx. Remember, this one we can just actually write the given integral. So now x e to the power x minus, we integrate e to the power x, the answer is e to the power x plus c. So now we are done. This is the simplest example you can get. So we managed to integrate using integration by parts. Okay, so that will be the solution. Now I want to go back to, okay, let's go here. Now number 2, we have the integral of x squared ln x dx. So is the integral of x squared ln x dx. Now we go to the hint again and check what they give us as a hint. So on the hints here, they say if you have x to the power n ln x, your u is equals to ln x and dv is equals to x squared dx. So we are going to use this hint. Okay. So our u is equals to ln x. Our dv is equals to x squared dx. Okay. So here we integrate both sides and we have v equals to x to the power 3 over 3. Now this side we differentiate. Du is equals to 1 over x dx. Okay. So that's what we have there. Now we write down our formula. Our formula is the integral of u dv is equals to uv minus the integral of v du. Now we substitute our u and v here is u is ln x and v is x to the power 3 over 3. So it's x to the power 3 over 3 ln x. So minus, we substitute our v, is the integral of x to the power 3 over 3 multiplied by our du dx. du is 1 over x dx. So here we can see we have like terms. This guy will cancel this one and that one. We have x squared 3. So this becomes x to the power 3 over 3 ln x minus the integral of 1 over 3 x squared dx. Now integrating again, x to the power 3 over 3 ln x minus 1 over 3 multiplied by x to the power 3 over 3 plus c. So this simplifies to x to the power 3 over 3. Okay, let me just write it simple. Avoid this complication. Ln x minus x to the power 3 over 9 plus c. So this is our solution, simplified solution. Okay, so this is problem number 2. Now let's go back and check the other problem. Number 3, the integral of arc sine dx. Okay. Okay. The integral of arc sine x dx. So again, we check our hint. What does they give us as a hint here? They say if we have this situation, arc sine x will be our u and dv will be x to the power n dx. So in the situation that we have, this will be the case. So we let u to be equals to arc sine x, and then dv is equals to dx. Now when you differentiate arc sine x, what is your answer? Du is equals to, is it 1 over the square root of 1 minus x squared dx? Okay, so this is the derivative. Now we write down our formula. The integral of u dv is equals to uv minus the integral of v du. Substituting our u and v, so if you integrate here, the v is equals to x. Okay, substituting, this means we have x arc sine x minus, now we substitute v, so this will be the integral of x over the square root of 1 minus x squared du. Dx, let's just put dx, the equivalent. Okay, so here we can write the given integral, arc sine x dx. Okay, this is equivalent to, now we have to integrate this integral here, this one. Let me just highlight this one. So to integrate that integral, what do we need? Here from this integral here, you can let u, I think we should use something different. We can let w to be equals to 1 minus x squared. So this means dw is equals to minus 2x dx. Okay, so this means we have minus 1 over 2 is equals to x dx. So we are going to substitute it now and simplify. So this means this integral now becomes, this is arc, the integral n plus. Okay, the integral of arc sine x dx is equals to x arc sine x. Now to integrate this one, minus, let's integrate. You substitute there, it's going to be the integral of u. Let me just write everything. So this is w here, dx. Okay, so on the next step we have x. I'm doing step by step. So if I'm writing the test, I'll just do this in 3 steps. But for now, I'm just doing step by step. So x dx, we replace it as minus 1 over 2 dw here. So it's going to be minus 1 over 2 dw over the square root of w. And this becomes, this is minus here, the integral minus 1 over 2 w to the power minus 1 over 2 w. So integrating again, so this will be, if you add 1, it's going to be the square root of 1 minus x squared over half, and here we have half, so half and half cancel out, so this will be plus c here. That's where my formula, my answer will end. So you can fill in this one, x arc sine x equals to x arc sine x minus the square root of 1 minus x squared plus c. So this is how you do integration by parts. You can see we are filling parts by parts there. Okay, I'm doing them because they are different. That's why I'm doing all of them, so that in a major test we'll get one of these. Now I was doing number 3. Now we go to number 4. X squared sine x. Okay, now let's check the hint. The hint, what does this, is this one here, is this one. So we'll let u to be equals to x squared, and then dv is equals to sine dx, sine 2x dx. Okay, so on the next one we are integrating. I have to make sure this is the case. Is what? Sine x squared sine, there's no 2. Okay, it's fine. There's no 2. We'll just do it as it is. So it's x squared sine x dx. So they said we let u equals to x squared, and then we let what? V equals to, so this is not necessary, v equals to sine dv equals to sine x dx. We differentiate u, this will be du is equals to 2x dx, and here v is equals to is what is negative cos x. Okay, now the integral x squared sine x dx is equals to negative x squared cos x. Okay, minus the integral of, now we substitute v, so it's going to be plus because of this negative sign, and is v is cos x, and then multiplied by 2x dx. Yeah, I put it on that. Okay, thank you. We have minus x squared cos x. Let's see here. Now again, you can see here we have to use integration by parts again here. Okay, so I'll just erase this one and focus on that integral. So this integral here is the integral, this integral 2x cos x dx. So on this one, we let u equals to 2x and dv equals to cos x dx. Now differentiating, we have du is equals to 2 dx. Here we have v equals to sine x. Now substituting back here, we have the integral. I can just write it here. So this integral becomes, so is v times this, so it's 2x sine x minus, now the integral of, we substitute v is sine x dx. You can put 2 here, 2 dx. Now I can finalize my solution now. I'm going to bring it here. The solution of that one is equals to minus x squared cos x. Now for this one here, this one here, we'll replace it with this. So it's plus 2x sine x minus 2x sine x minus 2. And then when we integrate, sine is going to be negative cos x. So it's going to be plus cos x plus c. So this is the solution. Okay, so here we have used integration by parts twice. Okay, so that's the situation. Okay. Okay. The next one is number 5, sec to the power 3 x dx. Okay, let's do that. So now we are going to integrate the integral of sec to the power 3 x dx. So this can be rewritten as sec squared x sec to the power sec x dx. Okay. Now you must help me here. Which one is simple to differentiate here? The one that is, when you differentiate tan, your answer is what? Tan x. Okay. It's sec squared.
Yes.
And then when you integrate sec squared, let's look for formula sheet and discuss it, okay? Sec squared, can you see number 13? Number 13. When you integrate sec squared du, you get tan u. So this means we can integrate sec squared, okay? So I'm guided by that. So I wanted to show you what guides me. So this means we can let dv to be equals to sec squared x dx, and then u is equals to sec x. So let's see, when we differentiate sec x, what do we get? We can go back here. So this is the integral. Let's see, sec x, or is sec x tan x, okay? So du here will be sec x tan x, and v here will be equals to tan x. Okay, now let's substitute. Now this integral, the integral of sec cube x dx is equals to, now is u multiplied by v. This will be sec x tan x minus the integral of, now we start by substituting v is what? There's dx here. I forgot dx here. Okay, this will be tan squared x sec x dx sec x dx. Now, this is equivalent to sec x tan x minus the integral. Now here we can replace this one as sec squared x minus 1 sec x dx. So I think you can check that identity, or you can just check it on in the formula sheet if we have one here. Where is that one? The one that involves tan and sec is this one here, number 42. Okay, so I've made tan the subject, so it's okay. Sec squared minus 1. Okay, now let's multiply. So here we have sec x tan x minus, then let's multiply out. We have sec to the power 3x dx minus or plus the integral of sec x dx. Okay, now if we look at this one, we can see the like terms. These are friends. This guy here is the same as this one. So we can say we have 2 sec to the power 3x dx is equals to sec x tan x minus the integral of sec x dx. So this implies that we have 1 over 2 sec x, this is what we are looking for, is equals to 1 over 2 sec x tan x minus 1 over 2 ln of sec x. We can check on the formula sheet. I wanted to write it directly, but you can check. Where is sec x? When you integrate sec x, this is the answer, number 10. Is ln of sec x plus tan x plus c. Okay, so that's what I wanted to write down there. ln of sec x plus tan x plus c. So this is the solution. Okay, I hope you'll remember all those steps. But for calculus, we have to practice. It's not the same as linear algebra. Linear algebra, if you know the methods, you can always solve that problem because you know that I'm supposed to determine the determinant. So if you know the determinant, you can determine the determinant of everything. But with calculus, you must do different problems and practice every day so that it becomes permanent. Okay. Now let's go and check the last problem. The last problem is e to the power 3x sine 2x. So we check the hint. According to the hint, we should let u equals to sine 2x and let dv equals to e to the power 3x dx. Okay. Now immediately after this, now I'm going to teach you a TUT method. This one is the standard method. So I'm going to solve the problems again. Okay. So this is e to the power 3x sine 2x dx. So here I choose my u to be equals to sine 2x, my dv dx here. No, dx will come this side. dv is equals to e to the power 3x dx. Now v is equals to 1 over 3 e to the power 3x, and here du is equals to 2 sine cos 2x. Okay, now we substitute the integral. Okay, this time we must give it a name. There's a reason why. We call it I, so we can let this equals to I. So I is equals to, come in. I is equals to Sorry. I said we give it a name I. So this is I. Now let's substitute. So it's going to be 1 over 3 e to the power 3x, okay, sine 2x minus, using the formula. I think now you master the formula. Minus the integral, we substitute v, 1 over 3 e to the power 3x. Now we multiply it by this dx here. Multiplied by 2 cos 2x dx. Now you can clearly see that this one also needs integration by parts, this part here. So we are going to integrate it again. Okay, so I don't know how to, let's write it as 1 over 3, the integral of e to the power 3x, there's a 2 here, cos 2x dx. So I'll just write the constant outside here. So we let u equals to cos 2x, and then we let v equals to dv equals to e to the power 3x dx. So integrating here, v is equals to 1 over 3 e to the power 3x, and then du here is equals to 2, negative 2, sine 2x. So this is a sine. Okay, now substituting. I'm going to substitute here using a different color. So u and v is going to be 1. Remember, multiplying by 2 first. 2 over 3, and then substituting my u and v, so it's 1 over 3 e to the power 3x cos 2x, okay, minus the integral of what? The integral, we substitute v, 1 over 3 e to the power 3x, now multiplied by this dx here, multiplied by minus 2, then that minus 2 here will make this one positive here. Okay, and then I can just put the 2 outside here, minus 2, so this will be sine 2x dx. But now when you look at it now, the reason why I make it to be I here, so this guy here is basically my I. Can you say that is I? Is the same, exactly the same like the given problem there on top. Okay, so now I want to finalize my solution. I have I, this one, I here, I is equals to 1 over 3 e to the power 3x sine 2x minus. Now for this integral here, this one, I'm going to replace it by this one here, the blue one. So it's going to be 2 over 9 e to the power 3x, okay, e to the power, that's the case. Okay, let's see, cos 2x. Now let's multiply, I must close the bracket here. So 2 over 3 multiplied by 2 over 3, that will be what? 9 over 4 plus, no, it's not plus, because of that negative sign is going to change, so I must respect that. It's going to be negative, isn't it? Okay, so we have negative 4 over 9 e to the power, no, there's no e, negative 4 over 9 I, because I said this is I, that's what I said. Okay, now we have I plus 4 over 9 I is equals to 1 over 3 e to the power 3x sine 2x minus 2 over 9 e to the power 3x, okay, cos 2x. Now here, working this out, I have 13I over 9 is equals to 1 over 3 e to the power 3x sine 2x minus 2 over 9 e to the power 3x cos 2x. Now from here I make I the subject. Making I the subject, so this means 1 over 3 will cancel out, 9 will cancel this. We have 3 over 13 e to the power 3x sine 2x minus 9 and 9 they cancel out, so we have 2 over 13 e to the power 3x cos 2x plus c. So this is my solution. So it ends there. So this becomes my solution. So any questions up to this point here? Before I do a TUT method, I'll arrive at the same solution. Okay, I can see there's no question now. Let's do TUT method. Okay, so for TUT method, you start with this big weight, detail. So for detail here, D stand for dx, E stand for exponential, T is trig, or sometimes you can just, it will be in the same level of hyperbolic function. A is algebraic, I is inverse. Inverse what? Inverse trig or hyperbolic. And then L is logarithmic. Okay, so this order that we have here is the order of integration. So if we have dx in the expression, dx, you start, you choose dx for integration. This is the order of integration. So it must go in this order, starting from D. You start from D, E, T, A, I, L. That's the order. Okay. Now, let's say we go to the given expression here. So dx, let me show you where we'll use dx. Let's say, for instance, number 2. Maybe I'll do 2 problems to explain where you use dx. Okay. Oh, even here we have seen on number 3. So I'll use number 3. Okay. So we have seen that we integrated dx. That's where we have a situation where we integrate dx. So let's do the TUT method. Let's start with number 1. Number 1. So this method is a table method. Okay. On the first step here, we have sines, and then we have differentiation, then we have integration. So sometimes, because we know for differentiation we use u, for I we use v. So I usually just write, okay, I'll correct that. I usually write u here and v here. Okay. Now, let's start with the first expression, e to the power, it was x here, e to the power x dx. So according to this, exponents comes before algebraic. So algebraic is x, your x squared, and so on. Those are algebraic. Exponents here, we are specifically speaking about e to the power x. E to the power x here will be our exponent. So it means here that we are going to differentiate x. So is x, when you differentiate x, the answer is 1. The sign starts with positive and is negative. For v is e to the power x. We integrate e to the power x, we get e to the power x. Now, this is how you cross. You multiply this by that one, and you multiply this by that one. And always you must put on the last term, you put the integral sign. So the solution here is that the integral of x e to the power x dx. Now we multiply x multiplied by that is x e to the power x, and according to the sign this will be negative the integral of 1 multiplied by e to the power x, which is e to the power x dx. So we have x e to the power x minus e to the power x plus c. So this is the solution. You stop. Okay, then we are done. That's the solution using this TUT method. Let's do the next problem using this method. This method, I think that, I don't know, number 2, we'll choose which one you use. Number 2 is x squared ln x dx. So we have the integral of x squared ln x dx. Okay, let's do this. So we know on top here we have sine, u, and v. So we choose ln x according to the detail. According to detail, logarithmic is last. So the last one here on the list, we choose, you can see that algebraic comes before logarithmic. So we choose algebraic for integration. So this will be x squared here. So differentiating here, we have 1 over x, and here integrating is 1 over 3, x to the power 3. And we have positive, negative. So with ln x, you always do only once like this, twice, 1, 2. Whenever the expression involves ln x, we do it twice only. Okay, so this is the previous one, depend on the x. If it was x to the power 3, it will be different. It will be 3 times the previous one. But with ln x, x squared ln x, you always do it twice. So you put the integral like I said. So the solution to this one is 1 over 3 x to the power 3 ln x minus the integral of 1 over x multiplied by 1 over 3 x to the power 3 dx. Now integrating, this is 1 over 3. This is 1 over 3 x to the power 3 ln x. Now we integrate, you can see here x and x will cancel out. We integrate x squared will give us 1 over 3. So we have minus 1 over 9 x to the power 3 plus c. Integrating this one. Like I said, if once you master this, you reduce the steps. Because I have done it before, I'll just write it directly. Okay. Now going back, we did number 2. Number 3 is similar to this one. We just do it in 2 steps. Number 3. So we are integrating the integral of arc sine x dx. So this is our table. So this is sine u v. So we differentiate sine. All right, I'll use this form, sine inverse of x. The answer is 1 over the square root of 1 minus x squared. And you have positive, negative. We integrate dx here. The answer is x. Okay. Now you cross multiply. So this is how you multiply. This is how you multiply. On the last one, you put the integral sign. So the solution to this one is x sine inverse of x here. Now we integrate minus the integral of x over the square root of 1 minus x squared dx. Now this is equivalent to x sine inverse of x minus the square root of 1 minus x squared plus c. You're done. Okay, so what can make you struggle is to integrate this integral here, but we have done it. That was the solution. We have dealt with this one. Number 4. Number 5, I don't think this method will work here. but you can try it. Usually when I'm solving number 5, I use the previous method. So let's do number 4. The integral of x squared sine x dx. So according to detail, which one comes first? Trigonometry comes before algebraic. So we integrate trigonometry. So this will be the case. We have sine here, we have u and v. So we differentiate x squared, we integrate sine x. Now, with this one, you differentiate until you reach 0 here. Then that's how you stop here. So it's going to be 2x, 2, 0. Positive, negative, positive, negative. Then sine x, when you integrate, is negative cos x. When you integrate the negative cos x, is going to give you negative sine x. And then we integrate again, it's going to be positive cos x. And the last one, you put the integral sign. So this is equivalent to, now you are multiplying. This is how you multiply. You multiply with 2 and you multiply in this fashion. So it's going to be minus x squared cos x. And then you have minus negative, and negative is going to be positive 2x sine x. Okay. Okay. Positive 2x sine x. Now you multiply 2 by cos x plus 2, the integral of cos x dx there. Okay. Let me try to make some space, dx. And then when you multiply by 0, everything will be 0. So this means we have minus x squared cos x plus 2x sine x plus 2 sine x plus c. So this becomes your solution. Now, like I said, number 5, I've never done number 5 using that method. You can try it. So I'm going to do number 6. I'll jump number 5. Number 5, you have to use the law method, or you have to learn how to use that one. I don't want to put myself under stress. Okay, so the integral of e to the power 3x sine 2x dx. So we check detail again. So e to the power x, which one comes first? Exponent before trig. So we integrate exponent. So this will be sine u and v. So we integrate e to the power 3x, we differentiate sine 2x. So differentiating sine 2x, this is 2 cos 2x. Differentiate again is minus 4 sine 2x. So it's positive, negative, positive. So with this one, if you started with sine, and then when you get sine again, you stop. That's how you stop on this one. So I stop there. I only do it 3 times there. So I have 1 over 3 e to the power 3x, 1 over 9 e to the power 3x. Now this is how I multiply. I multiply in this fashion, and I multiply in this fashion. And the last one, don't forget to put the integral sign. So the solution here is 1 over 3 e to the power 3x sine 2x minus 2 over 9, or 2 over 3, 2 over 3 cos. How do I multiply? This is the way. I want to make sure that I'm writing the correct thing here. Seems like I'm writing wrong stuff here. So I multiply diagonally. So it's going to be 2 cos plus minus 2 over 9. Is that the case? 2 over 9 e to the power 3x cos 2x. Check that. Okay. Minus 4 over 9, the integral. So you must be careful. This one, you can see when I multiply first, I didn't put the integral sign. The integral sign will come only on the last one. You must be very careful with that. That's where you can make mistake. So this will be e to the power 3x sine 2x dx. Okay, now we can clearly see now that this guy here is exactly the same as what we have here. So we can basically write this. If you don't want to use I, you can write it as 4 over 9 plus 1. Then you put the integral outside. E to the power 3x sine 2x dx is equals to 1 over 3 e to the power 3x sine 2x minus 2 over 9 e to the power 3x cos 2x. Okay, I'll just put plus c on the final answer, or you can put here, it's fine, plus c, it's not going to be affected, but I usually put on the final answer. So we have the integral of e to the power 3x sine 2x dx is equals to, now here we can see we have 13 over 9. So if you invert it, we end up with 3 over 13 here, e to the power 3x sine 2x minus 2 over 13 cos 2x plus c. So this is the solution, and my presentation for today actually ends there. Okay, now I'm going to stop the video so that can be available. Okay, any questions? Okay, let me make the recording available, then I'll end my class. Let me check if it's available. Yeah, so let's wait for the recording to be available so that I can share it immediately.